This is a video on the ESP32, its ADC, and the PT1000, what they are and their purpose in your project work. The ESP32 is a 12-bit microcontroller, and we use it to communicate with the thermometers and to collect data from them. It is programmed using Arduino IDE, which there is an entire series on in this YouTube channel, so I do recommend you watch that. And there is also a lot of online literature on the ESP32. The PT1000 is an analog thermistor. We get the temperature across the PT1000 by calculating the resistance across it. An increase in resistance corresponds to an increase in temperature, and the datasheet of the PT1000 says what increase in resistance corresponds to an increase in temperature of 1 degree Celsius. The ADC is an analog-to-digital converter. The PT1000 is different from the other two thermometers because it is analog, it's not digital. The ESP32 cannot read analog values, it can only read digital ones. So the ADC, which is inbuilt into the ESP32, takes the analog reading of voltage across the PT1000 and converts it into a digital value which the ESP32 can read. Like I said, the ADC in the ESP32 measures the voltage across the PT1000, which we can use the voltage divider equation to change into resistance, and then we can use that resistance to calculate the temperature across the PT1000. I'll take a second to explain what we mean by analog and what we mean by digital. Analog is the way we observe the world. It means a quantity that is continuously variable. When measured and graphed, these quantities take the form of a continuous curve. By continuous, we mean there's no gaps, there's no jagged edges, and there's no asymptotes. It's just a smooth curve. Digital readings are what a computer uses to process data. It translates data into ones and zeros, and when it's graphed, it goes up in steps instead of being a continuous curve. These steps correspond to the sample size that the digital device can take. This sample size is called the resolution and is described by a number of bits. I'll give you a visual representation of bits in a graph. This will help you understand what bits are and how they work. When analog readings are graphed, they take the form of this, a smooth curve. Here it's a sine wave, but it's not always a sine wave. It's just a smooth continuous curve. Digital values are a little bit different. So I'll plot a 1-bit ADC. So if I go up here, ignore this code. This is just for me to plot a graph. But this blue line represents a 1-bit ADC. And as you can see here, there's two horizontal lines. One at 1 here and one at -1. So this means a 1-bit ADC has two possible digital readings that it can give you. The way we calculate how many possible digital readings a whatever bit ADC can give us is by taking the number of bits, which is going to be our exponent, and then putting 2 to the power of that exponent. So here it's 1, and 2 to the power of 1 is 2. So if I changed the exponent, or the number of bits, to 2 up here, there you are. So 2 to the power of 2 is 4. So we've got 1, 2, 3, 4. 4 different horizontal lines and 4 different values that we can get. So we can get 1, 0.33, -0.33, and -1. The goal with these digital graphs is to get them to look as close to the analog graph as possible. We want them to look as smooth as possible and to have as fine a resolution as we can. As you can see, 2 bits isn't really that good, so we'll up it to 4 bits. A little better, but still not great. 2 to the power of 4 is 16, so this will have 16 different digital readings that it can give us. We'll change it to 8. And so this red line, which is almost indistinguishable from the black line, it goes just along the line of the black line, almost looks like an analog graph itself. That's exactly what we want. Our ESP32 is a 12-bit microcontroller, so it has even better resolution than this 8-bit ADC here. We describe the reading that a digital device gives us as a digital reading. And it can only be one of these levels, one of these horizontal lines matches up with the y-axis here. So if we had a 1-bit ADC, it would only be able to give us two possible digital readings, 1 and -1. If we had a 2-bit ADC, we could get 0.33, 1, -0.33, and -1. When you're using the ESP32 to read the voltage across the PT1000, you'll need to convert this digital reading into a voltage. It won't just give you the voltage as in 3 volts or 2 volts. It'll give you a digital reading that you'll then need to use in an equation to get the voltage across the PT1000. But I'll explain this in the next video on the ADC and the ESP32.